And so when you start with the proof, always going to begin with what you have provided for you. So we're just going to copy down what was given. AC is equal to BD. Identify that as your given statement. And then let's take a look at what that is. So here's AC and here's BD. So those were given as being equal to each other. Okay. There's no way to interpret that first statement. Again, that's always going to be my first step. If you can interpret the given information, do that and get more specific regarding it. If not, you can move on to the next step, which to me is introduce all the elements from your end state. So I need to have AB introduced. I don't yet, so I'm going to insert AB. Now, it's not a requirement to do it this way, but again, it winds up being a really systematic and consistent way to approach it. When I introduce my elements, I always try to introduce them in their either in the form that's the most similar to the end state or in the form itself. So I'm going to introduce it as AB. AB is a part of a larger whole. So AB is equal to the whole, AC, minus the other part, BC. And the reason I chose those is I already have AC introduced, so I'm going to introduce it in terms of what I already have. So I already have AC in it, in the proof, so I'm going to use that. And anytime you're talking about the sum of the parts equals the whole, or a part equals the whole minus the other part, that's always considered segment addition. Okay, now, usually if you're using segment addition, you can include two steps. There's usually going to be two steps involved, not always, but usually. So I can introduce CD at the same step. CD is also a part of a whole, so the part is equal to the whole BD minus the other part, BC. So I can include that in my statement too. Okay. Once you get to this point, now you're looking to do one of two things. And here's where, again, it can go one of two directions. One possibility is we can transform one of our statements in step 2 so that it's nearly identical to the other. Okay, so what I'm going to do is I'm going to take this statement, CD is equal to, but instead of writing BD, I can make it similar to the statement for AB by replacing BD with its equivalent. BD is equal to AC. So all I'm going to do is take this statement, rewrite it by replacing BD with its equivalent AC, and I get the new statement. I get the new statement CD equals AC minus BC, and all I did there was I directly substituted one expression for another. So this is the example of substitution only. It's not an example of transitive property, and we're simply replacing one value with another. Okay, once I get it to this stage, though, I now have two things, AB and CD, that are equal to the same thing. Notice both of these are identical, not just equivalent, but identical. So two things equal to the same thing are equal to each other, allows me to make the statement that AB and CD have to be equal. And that's the example of transitive property. Now again, anytime you see transitive property, always included in that is the idea of substitution. So this is one of the ways that you can approach this. Okay, there's an alternative method for identifying step 3 and 4 here. Okay, so if you don't see this relationship where you're turning one statement into the other, then what you need to be able to see is the relationship that if you can make these two statements equivalent to each other, then you can replace A, B, and C, D with those. So that would be the alternative method. So if you took the equation from step 1, so now in this method, we're taking the equation from step 1, which is AC is equal to BD, and we're going to manipulate that equation. We're going to take that statement and we're going to subtract a BC from each side. Okay, and so that allows me to justify this using subtraction property. Okay, so all I did is I took this statement, I rewrote it, and subtracted the same value from both sides. And now that would allow me to take this expression, AC minus BC can be replaced by AB, and BD minus BC can be replaced by CD. And so the justification on that is simple substitution. We're straight across replacing it. We're not saying two things are equal to the same thing, therefore they're equal to each other. We're just substituting in values. And so that would be the alternative method. So you could have used that method instead.